Hi and welcome to my maths class. Today we are going to do a revision of all the grade 9 exponential rules. Now, if you go through the grade 9 rules, you will see that the first one is x to the power of m times x to the power n is equal to x to the power of m plus n. What does this mean? If I give you x to the power 3 times x to the power 2, it means you have 3 x's here and then you have 2. So in total you have x to the power of 5. Now look, if I added the 3 and the 2, I would also have x to the power of 5. The second rule is if we divide, if I give you x to the power of m divided by x to the power of n, I will get x to the power of m minus n. If we had 3 x's on top, so x to the power of 3 over x to the power of 2. X to the power of 3 over x to the power of 2. What can we do? We can cancel the x's and we'd be left with x to the power of 1. Now had I simply said x to the power of 3 minus 2, I would still get x to the power of 1. So the two main rules that we learn is when you are multiplying exponents, then their powers add. When you are dividing exponents, then their powers subtract. Now, what is most important is that you must notice that the base stayed the same. The base was x and it's still x. If you look at this example, the base was x and it's still x. Why would that be important? What we noticed with children is that if I give you an unknown, you can maintain the base. But as soon as I put a number in, what does the rule say? The bases stay the same, so I would still have a base of 2. And then I would add my powers. So I would have had x plus y. Now many times what we find is that the pupils change this base to 4. Because what they do is they say, okay, 2 times 2 is 4. But that is not correct. When you are doing exponents, the base is maintained all the time. Now let us do another rule. The first rule you understand, the second rule you understand. Now the third rule is slightly different. What does it say? X to the power of m in the brackets to the power of n is equal to x to the power of m times n. What they're saying is if I gave you x to the power 2 to the power of 3, my final answer would be x 2 times 3, which is equal to x to the power of 6. Now let's see what they are doing mathematically. They are telling us x to the power of 2 is repeated 3 times. But we know from the first rule that if I'm multiplying, I can add the powers. So I would have had x to the power of 2 plus 2 plus 2, which is also equal to x to the power of 6. So the easier method is, if I've got x to the power of m and then outside to the power of n, my final answer is x to the power of m times n. Now when we're doing this rule, sometimes there is more than one term inside the bracket. So let's say I have in the brackets more than one term. Now look at this one. We only had one term inside. We only had x. But inside the bracket now, I have more than one piece. I don't just have a y or I don't just have an x. I have 3 pieces to it. Can you see I have the 2 and then I have the x and then I have the y. And outside the bracket, I also have a power. Now, when we're doing this, you have to use the distributive law. Now, what did we learn about the distributive law? Your distributive law, we had learned that the P would go to every power inside. Now look at the difference. Before you would say the number outside will go to every term inside. That was when you were simplifying and when we had pluses and minuses. If you are not familiar with that, you need to go to your simplifying videos in grade 10. You'd find it on the summary of the grade 10 videos, or you'd find it under your grade 10 sections of simplifying. Now what do we know is that this P outside is going to every power inside. So we're going to apply rule 3 to every piece in the fourth question. So I'm going to have 2 to the power of P. Then I'm going to have X. Now what happens when we have already an existing power? We multiply the 2. So I'm going to say M times P. Then I'm going to have Y, N times P. Can you see that? So we're going to use rule 3 and we're going to combine it, and that's what creates rule 4. Now what is interesting is what happens to a sign that we have. When you have a sign inside such a question, it is also affected by the power. So if I had a negative sign here, then this P would also go to the negative. So you'd have negative to the power of P. Let us try an example. If I gave you negative 2, x to the power 3, y to the power 2, all to the power of 4. Now what they're saying specifically about the negative is that the negative is also repeated 4 times. Now if a negative is repeated 4 times, negative times negative will give me a positive. Positive times a negative will give me a negative. Negative times a negative will give me a positive. So my final answer would be a positive. That's how the 4 affects the negative. Then we've got 2 to the power of 4. Why is it simply to the power of 4? Because by the 2 there's an existing 1. If you don't know, you can simply put it. So what we're saying is 4 times 1. Then we're going to say x 3 times 4. Again, we're applying the third rule. Then we're going to say y 2 times 4. So what is our final answer? 2 to the power of 4, x to the power of 12, and y to the power of 8. Our sign in front would be a positive. Now let us take the same sum again, but instead of putting an even power, we now put a negative power. Now let's look at what happens to the negative. We have 1, 2, 3. Negative times negative gives me a positive. Positive times negative gives me a negative. So my answer is a negative. Then we're going to have 2 to the power of 3, x 3 times 3, y to the power of 2 times 3, giving us a final answer of negative 2 to the power 3, x to the power of 9, y to the power of 6. So what is our conclusion? If you look at this specific rule, when we have a negative in the question, then our fifth rule would say that negatives to an even power, negative to an even power will give us a positive answer. But negative to a negative power will give us a negative answer. Now when we are working with these negatives, we are specifically talking of the negatives that are in front of the question. Now positives do not affect us. If you have a positive times a positive, it will always give you a positive. Even if you have an odd number, positive times positive is positive, positive times positive is positive. So positive is never affected by this rule, but negative is always affected by this rule. So be wary when you have a negative in the question. Okay, the next rule says that even if I have a fraction with a power outside, the power would go to every piece that is in the question, which means this would give me x to the power of n over y to the power of n. So if I had x to the power 2 over y to the power of 5, and then I had it to the power of 3, this 3 would multiply with the 2, applying the third rule where we know if they are in brackets and both are powers, we multiply the power. So what am I doing? I'm going to say x to the power 2 times 3 all over y to the power 5 times 3. So my final answer is x to the power 5 all over y to the power of 15. Now, this can go further. What happens when we have a negative power? The next rule says that if you have a negative power, as soon as you bring it on top, the power sign changes. So, what happens is you have your 1 on top, you're bringing the x on top, but what happens is the power sign changes. So, if was negative, it becomes x to the power of positive n. Now, if you look at it, what are we actually doing? You are actually applying the second rule. If you think what they did here in the second rule, can you see it was x to the power of a positive n? As soon as they brought it on top, what happened to the n? It changed its sign. So likewise, when you are doing this rule, it is minus n. But as soon as it goes on top, now remember there's already a 1 on top, I'm bringing this on top. It becomes x to the power of positive n. So it's changing its sign. Now this rule doesn't only work if I'm moving from the bottom to the top. When you have a negative power, make it a fraction. Then take the entire exponent and move it from its position. If it's on top, move it to the bottom. If it's at the bottom, move it to the top. Now, I am emphasizing that you simply take the base and its power. Don't take any number that is with it. Only the base and its power. So we're going to move it and it would be 1 from the existing one times x, change the sign of the power, which is a positive 4. Now, if you have nothing on top, you would represent it by putting a 1. Let's do another example. If I gave you 3, x to the power minus 2 over 5. Now look, the only part that we're interested in is the base, which is x, and the negative 2. We're not interested in moving anything else. So I'm going to leave my 3 and my 5 in the positions that they are. But I'm going to take the base and its exponent and move it from its current position. So I'm going to move it from the top to the bottom. As soon as I move it, the power sign changes. Look at what I'm saying. The power sign changes. I'm not talking of the sign in front of the question. I'm talking of the power sign. Let's do one more example. If I gave you 4 over 2 x to the power of minus 3, what am I interested in moving? The x is the base, the power is negative 3. I'm only going to move that. So the 4 and 2 are staying in its position, but I'm moving the x to the power minus 3 from the bottom to the top. As soon as I move it, the power sign changes. So I got 4 over 2, and on top now I have x to the power 3. So my final answer is 4x to the power 3 all over 2. You can further simplify. 4 over 2 gives me 2. So my answer is 2x to the power of 3. Now what happens when they start implementing more rules? Let's take a fraction with the power outside. Now what we're doing is we're doing multiple rules. The one rule we know is if there's a fraction and there's powers outside and inside, what do? We multiply them inside. So first we're going to apply rule 6, which says x minus 2 times 3 over y to the power of minus 5 times 3, which will give me x to the power of minus 6 over y to the power of minus 15. So which rule we applied was this specific rule that said what the power inside multiplies with the power outside, and you do it to both the top and the bottom of the fraction. Now I'm going to try and apply the negative rules. I don't want negative powers. So what does it say? It says that if it is a negative power, I move it from its current position. If we're going to move it, I'm going to move this one down and I'm going to move this one on top. So when I move the x down, it becomes x to the power 6. When I move the y on top, it becomes y to the power 15. So my final answer is y to the power 15 over x to the power 6. Remember that you have to be able to implement all the rules together. The next rule we're learning is that any base to the power of 0 is equal to 1. So if I give you 10 to the power 0, it would equal to 1. If I give you x, y, z all to the power of 0, it's going to equal to 1. Now, the last section that we work with in exponents is root signs. Now, the rule for root signs is that you have the base, which is what we're calling here inside, right? That is our base. And then the rule is inside over outside. So what does that mean? That means I would have x and then the inside power is n over the outside power, which is y. Now you must remember that when we work with surds or root signs, the norm is not to usually put a power there if it's 2. So when they don't give us a power, then what we're going to do is we're going to accept it as 2, and like all our other rules, that says that when I'm applying a rule, it will apply to every piece that is in that term. So what happens is the inside-outside rule applies to every piece. So I'm going to have x. The inside is 1, outside is 2. The y, the inside is 1, the outside is 2. The z, the inside is 1, the outside is 2. Why am I saying 1? When there is no power given, it is accepted as 1. Why am I saying 2? When there is no power given in a root sign, then it is accepted as 2. Now let's make it a bit more challenging. If I gave you 25 x squared y to the power 4 and p to the power of 7, and we cube root it, then the rule is that it would also go to the number. So I would have had 25. Remember, the existing power is 1. So I would have had inside over outside. Then we have x, inside, which is 2 over outside. Y, inside over outside. P, inside over outside. So whenever you are working with this rule, it works inside over outside. Now what happens if we have a negative sign? The norm is that you would only get a negative sign with an odd number. And then your answer would also be negative. Even powers give me positive, negative powers will give me negative. With a root sign, only negatives would exist with odd. You would not get an even power with a negative surd. Let us do the next example. Now in this sum, we're going to first work with our root sign. When you're working with exponents, they look cumbersome. There's a lot of them on top of each other. You always try and get rid of the thing that looks the worst. Like root signs definitely outdo fractions. So you first try and get rid of the root signs. Now, this negative sign doesn't affect us when it comes to our rule of inside over outside, because it's simply in the question lying outside. Let's apply the rule only to this section. So we have m, inside is minus 6 over outside, which is 3. Then we have x, inside is 12 over outside, which is 3. All over. Now remember, if they don't give us a power outside, we accept it as 2. So we're going to have m, inside is minus 6 over 2. Now let's simplify our fraction. We have the negative sign. We have m to the power of minus 2, x to the power of 4, all over m to the power of minus 3. Now what happens? We've got a m to the power negative 2 divided by m to the power of negative 3. Now if you look, when they have fractions, we're going to say the top power minus the bottom power. So let's apply that rule. So we got our negative outside, m, what is the top power? Minus 2, plus the bottom power, which is 3. Why did I change the sign? You could change the sign based on two rules. One is that when you move it, it changes signs. Two, if I said top minus bottom, then look, it would have been top is minus 2 minus the bottom, which is minus 3. So that gives me m minus 2 plus 3. And then I still have my x to the power of 4. So my final answer is m to the power of 1 and x to the power of 4. Now, in grade 9, the basic solve for x you would have learned is that if you are given an equation, meaning it has an equal to sign, the first thing you would do is try to get the unknown and its base alone. Then you're going to reduce all the numbers to the lowest powers. So you try and bring all the numbers down to its powers, and once they have the same base, you're going to cancel and solve. Let's take this one. Now, get the unknown and its base alone. In this case, it's already done. The next thing is to reduce all the numbers to its lowest power. Now, 64 can become 2 to the power of 6. And on the left hand side, we have 2 to the power of x. Once they have the same base, I can cancel them. So I have x is equal to 6. Let's try a bit more challenging. If I have 6 times 2 to the power of x is equal to 48. Now look, the base and its power is only 2 to the power of x. So I want to get rid of the 6 first. How am I going to do that? I'm going to divide by 6. What I do on one side, I'm going to do on the other side. So I end up with 2 to the power of x is equal to 8. 8 becomes 2 to the power 3. And since we have the same base, we can now cancel and we have x is equal to 3. Right. Now, the next part is when they give you that the x is the base. Look at the difference in the question. Here, the x was the power. But now I'm making x the base. Now there's two ways of doing this. One is you could just root it with the opposite. So since this is 4, I'm going to root it with the power of 4 because inside over outside will give me 1. So I have x to the power 1. And what I do on one side, I do on the other side. And then you could simply press it into your calculator, which is equal to 2. The problem with this is that if you are going to go to university, entrance exams do not allow you to use a calculator. Now the mathematically correct way would be leave x to the power of 4. Reduce the number to prime numbers, which is 2 to the power 4. Now how do I get rid of this 4? We're going to times it by 1 over 4. That would allow the 4's to cancel. Then what I do on one side, I'm going to do on the other side. So again, the 4's would cancel, giving me a final answer of x is equal to 2. Now you would notice whenever they give you these sums, most of them also reduce to the same power. Like if they give you x to the power of 3, then they would give you a number like 27 because it's a perfect cube. So this would become 3 to the power 3, x to the power 3. To get rid of it, the opposite is 1 over 3. What I do on one side, I would do on the other side, and that would give me x is equal to 3. Thank you for watching.